So today we're going to talk about binary logistic regression. Last week we talked about linear regression, bivariate linear regression. So we use examples of this data. So let me take this particular data set to show what is the difference between the two. Okay, look at the data set. BMI versus SBP. Are they both quantitative? Are they
Yes.
both quantitative, right? Then what you do, you can scatter plot and the results are like this. So what does it mean here? Generally, higher the BMI, higher the BP, isn't it?
Yes.
We see there is a pattern. But the question is, are we interested in actual BMI or group it into, sorry, before that, and then we plot the line. So that's a linear line, and that's the equation, and we interpret this value. Every 1 unit increase in BMI, BP expected to increase by 4.12 units. Now, what if I just categorize them? I'm not interested in actual BP. I just want to know whether the high BP or normal. Let's say cut at 140. Categorize them. Anything less than 140, normal BP. Anything more than 140, high BP. Supposing I don't have this value, how many variables are there now? How many variables are there? How many variables?
2 variables.
Yes, now, how many variables here?
2.
Are they quantitative or qualitative?
Quantitative.
Quantitative.
For the quantitative, therefore I can do regression to get the slope. But now,
Only
how many
one.
variables are there?
Oh, only one.
How many variables are here? How many variables?
Just the one.
Just one. How many variables now?
2.
2 variables. Then what I did, I just categorized the age, the BP, into 2 groups, and I remove this. How many variables are there now?
Just the one.
Just one variable.
2. Actually 3.
3, right? This is one variable. This another variable, right?
Okay.
SPSS columns are variables, right?
Yes.
Here, how many variables? This
2.
one variable.
Yeah, right.
This another variable.
2.
2 variables. What I did here was, I just categorized this part, right? I just categorize this. We put a different color. Categorize these values into normal and high. I'm not interested whether 132 or 135. As long as below 140, I consider normal. So I don't need these values now. Right. So now, how many variables are here?
2.
2 variables. Quantitative or qualitative?
One quantitative and the other is qualitative.
Qualitative. Just now, are they quantitative or qualitative?
Quantitative.
Both.
Which is dependent, which is independent?
BMI is independent and SVP is dependent.
BMI is independent variable and BP is
Dependent.
variable. Right. Now, in this exercise, which is dependent, which is independent?
BMI is IV.
BMI is IV, and this is your DV. Now, same like just now, this is what you have originally. Okay, if I have originally this, what's my objective? What's my objective for collecting this variable? What's the objective? What do you want to know? Here, what do you want to know?
To find out if SBP is dependent on BMI.
To test if SBP depend on BMI. How about here? What I want to know? On the left hand side, right hand side, what I want to know?
To find is if SVP is within the range or higher based on the BMI.
No, does SBP category depend on BMI, right?
Yeah.
Just now, does SBP depend on BMI? Regression. Now, does SBP category, whether normal or high BP, depend on BMI? Correct?
Yes.
Right. This both are quantitative, we use regression. But here, the dependent variable is qualitative, right?
Yes.
So what analysis we do? Supposing I blindly follow scatter plot. That's how the dot's going to be. See normal, eh? These are normal here. These are the values. So your graph will come until here, all are below normal. After this, all are high. Can I draw the line this way?
No.
No. Yeah, they don't represent the dots anymore because here is no more actual BP categorized already. So is this graph better?
Yes.
That's called the sigmoid curve. So you can't do simple linear regression, cannot. This dot, this line does not cover the dots. The sigmoid curve, actually, there's no real line here. There's no real line. Dots are here after the certain threshold, and you're going up here. Looking at this, roughly what can we say? After BMI reaches 29, your chances of high BP goes up, right?
Yes.
Let's say about 29 and above, these people high BP. Below 29, these are normal BP. So basically you want to know what's the cut point that can be used to determine the BP group based on BMI. That's where research comes in. Many medical research, whatever area, economics, agriculture, they all are guided by these kind of things. Now, look at the two comparison now. This regression, this is my logistic regression. This method is called OLS. This method is called maximum likelihood estimate. Here you want
One of our students, he got disconnected and is in the waiting room.
okay. Nobody? There's nobody there?
Yes, Prof.
Are you in? Waiting.
Yes.
Anybody waiting outside?
I think it's Zabir.
Yes. I don't see any in the list. I'll check again. Right. On the left-hand side is regression. This is logistic regression. Right? This method is called OLS. What's OLS?
Ordinary least squares.
Least square. That's where the residual comes in. Maximum likelihood estimation. All those in computer science, you should be familiar with this. Here we get the equation. SBP equals to A plus B BMI. Here we get the equation something Z. Z equals to A plus. Now the right hand side of these equations, are they same?
Yes.
Right? We're talking about combination of BMI, right? Okay, the right hand side of the equation.
Yes.
Right? Okay. The right hand side equation, are they quantitative? Is it this quantity? Is it right hand side? The value, is it quantitative or qualitative? BMI quantitative or qualitative?
Quantitative.
So multiply, add all this will be quantitative, right?
Yes.
Here also all quantitative, right?
Yeah.
So if I get the equation, if I want to predict the BP, example, let's say BMI is 30. If this is 2, this, let's say, is 70. What's the answer here?
130.
So this will be BP equals to 130. If I do the same thing here, if I do the same, exactly same thing here, this will be 130, right? I might change the value bit, okay? This is 0.1. This is 0.3, 4. The BMI is 30, same person. So what's the value here now? What's the value?
3.4.
Yeah?
3.4.
3.4. So what's 3.4? What is 3.4? What is this 3.4? Ours says whether high or normal, right?
Mm.
Is it right?
Yes.
Where this 3.4 came from? Because Z is a latent variable. It's not real. Latent means not real. On this side, it's a real variable, SVP. Whereas the equation, in this equation, Z is called the latent variable. As you go, you'll come to more understand what is the latent variable and what it's used for. So basically, regression equation, in regression analysis, we get an equation to predict the BP. In logistic regression, our purpose to get the Z value, which is not real, we call it latent, centered 0 plus or minus. It's called a Z distribution. Have you heard about Z distribution? Standard normal distribution? Have you learned normal distribution?
Yes, Prof.
Right. Z, in this case, centered 0, plus 1, plus 2, plus 3 to the right hand side, minus 1, minus 2, minus 3 left hand side. It follows a standard normal distribution. Later we'll see how this is used to our interpretation. Okay. The link function. Now, what's my objective of this study? What's my objective here? What's my objective here? By what to write my objective? What is my objective?
Does SPP category depend on BMI?
So, to test the association between BMI and BP as BP category, right? Or you can also say whether BP is high or normal, right? No more actual BP, whether high or normal. To test association between BMI and BP category. BP categorized into these values. So now my objective is this. So now this could sound a bit complicated at the beginning. Just watch. This is my equation. This equation I obtained from here. My objective is to test association between BMI and BP category. BMI and BP category. That's my objective. So I get the Z function, and this is called link function, linking to what I want. Probability event. In this case, the event is high BP, governed by this equation. Right? So I want to leave it here. Could be very confusing. I'll come back to this later. Right? Before that, when Z is 0, what is this whole value? Z is 0, what is the value?
0.
1/2.
Huh? E power Z. When Z is 0, what is E power Z? E power 0.
E power 0 is 1.
1. So this is 1. Numerator become 1. When this is 1, this is 1, What's the value?
0.5,
0.5.
1/2.
So that is Z0. When Z0, chances of the person having BP is 50-50. Right? Now, as your E increases, what happens to the function? As your Z increases, what happens to this function? Getting bigger or smaller?
Bigger.
This whole
Smaller.
smaller?
Smaller.
The E power 10. Let's say this is 10. Okay, this is 10. So what's the value? What's the value now? This whole thing, probability of event, is it big or small? Yeah? Smaller. Exponential 10, you know.
Yeah, but its denominator is +1, right?
+1, but this very big value, +1, almost nothing, only this value, right? If this is 1 million over 1 plus 1 million, is it towards 1 or towards 0?
Towards 1.
Towards 1.
Yes.
So if the Z is positive, it is more likely to be hypertensive. Z is 0, 50-50. Z is negative. Now what's the answer? Negative. What's the answer now? Big or small? This value.
Or minus
E power minus 10 is almost 0, right?
0. Yes, smaller.
Almost 0.
Yes.
So whether you're going to hypertension or not, all depends on Z value. All depends on the Z value. Look at example here. When Z equals to 1, we put in the value Z equals to 1, we know what are the chances of the person having high BP. Right? Time being, let's not go in detail of this. This is what people are using for prediction. Right? When you go and ask for loan, the bank asks for loan, did they straight away give you a loan? When you ask for a loan in the bank, do they straight away give you a loan?
No.
What do they ask for you? Ask from you? What do they ask from you? Yeah?
Credit profile.
Yeah? Fill up a?
Like credit analysis, they
They ask
carry.
you to fill up a form, right?
Yeah. They take your
Fill up the
details.
form, what they're doing, they're collecting information, isn't it?
Yes.
After they put into computer, they'll tell you what are chances of you not paying your loan.
Yes.
Prof, excuse me, Prof. There is still the student who couldn't get into.
All right.
Uh,
Now, are they in?
The student who couldn't enter the class is still in the waiting room.
Yeah, I'm trying again. Joining. All right. Is in there? No one. All right. That was in. Right. When you apply for insurance, what question do they ask? Life insurance. When you apply for life insurance, what are questions they ask? Typically, what questions they ask?
Your health history.
Age.
Past health history. Come on.
Age.
Age. Did they ask your weight and height?
No.
Insurance company don't ask for your weight and height. Life insurance.
No, definitely. They'll ask.
They take our medical records, right? So,
No, life insurance apply to life insurance company. They give the form to fill up. You also measure height and weight. Based on height and weight, actually, what are they measuring?
BMI.
BMI.
Right. They know BMI is a risk factor. So the company uses this kind of link functions, this kind of measurements, equations to predict the chances you making a claim within 1 year, 2 years, 3 years. So this is very, very useful functions in whatever area, right? In making decision. Okay, so I don't go into this yet, odds ratio. Right, let's see an example first. Example, the same data set. Let's do this. What's objective? What's objective here?
To test if there's an association between BMI and SBP.
Earlier we did BMI and SBP, right?
Yes.
Now you're talking about BMI and SBP
Category.
category, right? So let's go back to your data. Your data. Is it more confusing compared to linear regression?
Yes, it is.
It is, but there will be some assignments on this, better than now. Okay. Let's start with regression first. BMI and SBP. Okay, BMI and SBP, these two variables. Are you okay? Okay, let's do. Let's do this first. What's my objective? What is my objective?
To test the category of a
As it is now.
To test association between BMI and SBP category.
Okay, what analysis will you do? What analysis will you do? Are they both quantitative?
Yes.
Yes, we'll do linear regression, right? Now do this. Right click on MC, right click on MC, insert variable. All right. Double click on this variable name. Go to variable view and type the sbp.cat. No space. sbp.cat. No space. Double click on this row number 8. Back here. Right. So I'm going to change the BP to BP category. There are many ways of doing it. I'm going to the easy way out. Right click on BP. Right click on BP. Sort descending. This is a high BP, right?
Yeah.
Am I right?
Yes.
Right. Until 140, until here. Let's name this 1 all the way up. Right. All this value you label as 1. BP. Is it more than 140?
Yes.
Right, 1. All the way, all those more than 140. Okay. Below here, let me see what the category is. If you put a 0 first, all the way down you put 0. Actually, I'm recoding that. Right. So I've categorized BP into 2 groups. As in the notes, right? I categorize the actual BPs into 2 groups. So 140, okay, 140, 140 is still high, right? 140 also put 1. Right. Are we done?
Yes.
All right. So I created another variable. This BP, this BP cat. Just now I did regression based on this linear regression. Now, if I don't have this, I'm going to compare these two. What's my objective? What's my objective?
Finding out a relationship between BMI and SBP category.
BMI and SBP cat. What's one? What is one?
High BP.
High BP, 0?
Low.
Low.
Common.
All right. So double click on SBP cat. Now you're here. Let's go and label them. One is high, 0 is normal. Label this so that you can remember.
Did you go to the label place?
Say again.
How did you go to the label?
Okay, where are you now? Are you here like this?
Yeah, no, I'm on that view.
Okay, double click on the heading. Can you see this as VP cat? Are you here?
Yes, Prof.
Right. Go to the right under the values. Under the values, click 1, tab, label is high. Enter. 0, tab, normal, enter. It's not coded 1 and 0. Now I'm telling what is 1, what is 0. Continue. Double click 7. Now I recode it into high and normal. Okay, 1 is high, 0 is normal. Are you all clear with this? Now, what's your objective now?
Prof, it didn't work for me.
Which one doesn't work?
I went to values and I added it.
Ah.
Then I press OK, and nothing happens to the label.
Now you see like this is there. Look at mine. Look at my screen. I see 1 and 0.
Yeah.
Now click this icon here, the label icon. This is icon 1 and A. This is icon.
Okay, I got it.
Like that. Right. Label.
Prof, excuse me, please. I'll go 20 minutes for prayer.
Okay. All right. Okay. Now you're ready for the analysis. The rest, you follow the notes. There's only data preparation. We are here. Ready. All right. So go to this analysis. Okay, we do it together one more. Also BMI, yeah? You do it. Let's check the results first. All right. There are so many tables. We're not going to go through all the tables. Highlight which tables are important. In your notes are given 3 tables. Anyone having problems? Okay.
No proof. I have.
Yeah, what is
So we choose the SBP category as dependent.
Correct.
Is our choose, or if there is some rules, we should choose it as dependent.
Okay, you put this first as VPCAT.
Yeah.
Okay, here BMI.
Yeah. I did this.
Okay, and go to options.
I mean, why we choose the SBP category as dependent? Why don't we choose BMI as dependent?
No. My objective is, does SVP category depend on BMI? Not vice versa, right? SVP category, high BP, does it depend on BMI, right? This is called dependent variable.
Okay.
Right. Okay, look at the output. This table, dependent variable encoding. That's very important table. Look at the table. What's the coding here? Is it 1, 0?
Yes.
Right. 0 is a reference group. 0 is a reference group. In other words, we are comparing what to what? We are comparing high to normal. Right? You're comparing high, the 1, 0 is a reference group. That means you're comparing high to normal. So this table, that's very important. Next table, Hosmer-Lemeshoff test. This tells you whether model fits or not. Hosmer-Lemeshoff. Did they ask for it? Hold on, I didn't ask for it. Okay. Hosmer-Lemeshoff, this is a test. Normally, this test, people say the p-value less than 0.05, it means the model fit is not good. However, people are questioning this particular test nowadays. At least for time being, I'm going to ignore this. Right, I'm going to ignore this for time being. Look at this table, variables in equation, the last table, variables in equation. This table. Okay, variables in equation. So I'm going to have the table here. All right. Is it similar to your regression table, coefficients table? Compare this table with the correlation table. We had systolic BP and BMI. So look at this table. This coefficient table, is it similar to this table? This coefficient table, are these two similar?
Yes.
In what way? The coefficients, right? The B coefficients, right? That's the B coefficients.
The values are different, but
No, the
the
table,
labels are same.
the content of the table, that's B here, the beta, the B coefficients here, right? The B is here, and same thing, the B here. Last time, what we did, we wrote the equation based on this, right?
Yes.
BP equals to 71
0.0.
2 times BMI. Same thing here, going to write. Instead of a SBP, you're going to put a Z there. Z is a latent variable. Just put Z first. What's the constant here?
Minus 10.25.
10 point something. Plus
0.310 BMI.
0.313 times BMI. The way we wrote the equation here and here, similar, except different analysis. All right. Now here, what you wanted to know in this analysis, whether BP depends on BMI, right?
Yes.
Right. P value less than 0.05, we say yes. In this table, look at the first row BMI. Is it significant?
It's less than 0.01.
Okay. My question is, does BMI category depend on BMI? Sorry, BP category, does it depend on BMI? So this P value is less than 0.05. Hence, BP category depends on BMI. Here my objective is, does BP category depend on BMI? We look at the P value, less than 0.05, answer yes. So you just write the equation. I don't want to go into more detail, just write the equation. These are positive and negative. Positive and negative. The coefficient is positive and negative.
Positive.
Positive.
Okay. So as your BMI increases, Z value will be more and more positive or negative. As BMI increases, on the right hand side value will be increasing or decreasing.
Increasing.
Increasing.
As BMI increases, Z will increase. That means what? Higher BMI, the chances of hypertension will be higher. So let's see how this can be used in prediction. Right? Let's go to show you in Excel. Okay, we get the equation. So what's the equation? Z equals to
Minus 10.25.
minus 10.25
Plus 0.310
plus
BMI.
0.310 times your BMI. So I'm going to make prediction for several various BMI values here. 20, 21, maybe 20, 25, okay?
Excuse me, Professor, is a 0.31, not 0.1.
0.31?
Yes,
Where?
0.31.
Oh, 310.
Yes.
310. 0.310. All right, thanks. So that's the equation. So I'm going to take a range of BMI values and see how to predict the respective BP, whether high BP, what a chance of high BP or not, right? Okay, let's say we start with BMI. Okay, when BMI equals to 20, what's Z? What is Z value when BMI is 20? What will be Z value when BMI is 20? What must you do? Equals to this value plus this value times BMI being 20. So that's a Z value. Can you check whether it's right or not? Put BMI 20.
Yes, it's correct, Prof. Negative 4.05.
All right. Next, what is my equation just now? The equation, the link function. Okay, that's a link function. Already changed a lot. Okay, e power z 1 plus e power z. Right. So that's my link function. Okay. So given Z, next is to find the e power Z. In Excel equals exp bracket the Z value. Okay, that's what I'm going to do. So equals to exp of this value. Right. Then the denominator. This is 1 plus exp of Z value. 1 plus that. So this will be 1 plus, I just watch it, okay? At least understand what is being used for. Finally, the probability of high BP. That's exactly what you want in the end. Okay, probability of high BP. So if I follow the equation now, e power Z, that's e power Z, over 1 plus e power Z, this is going to be this value divided by this value. Let's say change to percentage now. What are chances of a person BMI 20 having high blood pressure?
Very less.
Very small, right?
1.7.
Very small, right? Let's say BMI increases 22. What do you expect here? What do you expect here?
2%,
Increase.
1.7, 1.8% increase.
Great. How many percent increase? Sorry. How many percent increase? Okay. How much increase?
Around,
Almost double.
yeah, almost double.
So as the BMI increases, let's see what are chances of this BP is becoming more and more hypertensive. Maybe I replace these values with this is negative 10.25 and this value times 0.310. Okay, let me do again. So this equals to negative 10.25 plus 0.310 times this value. All right. Let's fill up another value. BMI increasing. Let's see what happens with the as the BMI increases, your chances of high BP is it increasing?
Yes.
Right. Let's pull down more. Let's say, let's go to 3 other levels. And the BMI is increasing 29, 30, 31, right? Actually, what are you interested in this? A person wants to know what are chances of me being hypertensive. So ask him, what's your height, what's your weight? It tells height and weight, calculate BMI. Supposing I have this formula from past research, so I put this in, I'm able to, this is something like telemedicine, so I can tell what are chances of he having that particular problem. Let's say now, keep on increasing. What's happening? When the BMI increases, what's happening here? Like BMI 42, almost 95% sure the guy is going to be hypertensive. Right? So this is the kind of model people develop again and again and put to test that works. Then you know BMI is a risk factor for hypertension. So time being, we just want to know whether BMI, BP category, hypertension, or normal, does it depend on BMI? That's my objective. From here, the values we got from the table, we say yes. Does it depend on, I'm moving. Right, we read this value BMI in these variables in the equation. BMI, this P value is significant. Yes, BP category depend on BMI. How we arrive the equation? With this equation, given a person's BMI, we're able to predict his or her BP level. Are we clear?
Yes, Prof.
Right. If I plot these two, what kind of curve will I get? Is it an S curve? More or less, is it S curve?
Yes.
Right? So what's happening? As your BMI increases, what's increasing now? What is increasing? What is this axis?
The chances of high BP.
Chances of high BP. As your BMI increases, your chances of high BP increases. Let's say I cut 50%. What's the BMI beyond which 50% sure you're going to be hypertensive? So what's the cut point for it? What's the cut point for 50% chances? 50%, drop down. What's the BMI?
34.
34. When BMI 34, almost 50% chance you're going to be hypertensive. As your BMI increases further, and your chance of high BP increases tremendously. Right? So that's a moral of the story. So in this class, we don't want to go into details of the analysis. In this class, we want to know what are the factors associated with an outcome. Right? Let's do another example. Another example. There's one variable DM. DM, diabetic, and BMI. Diabetic and BMI. What do you want to know? What do you want to know? What do you want to know?
Diabetic depend on BMI.
Right. The BMI, does it depend? Sorry, diabetic.
Diabetic.
Does it depend BMI? Before you proceed, look at the diabetic. It's coded 1, 2, right? Isn't it?
Yes.
What's 1?
Yes.
2 is no, right?
Yes.
Change all the 2 into 0. Change all the 2 into 0. How do you do that?
We go to variable view and change in the value of DM.
Okay, that's 1. Now I change this, okay? I change MC. MC is better. Look at MC. MC1, medical leave. MC means medical leave. Medical leave. Right?
Yes.
What's 1? Yes. What is 0? No. What do you want to know? What do you want to know? MC depends on BMI or BMI depends on MC? Medical MC is medical leave.
BMI depend on MC.
BMI depend on MC. You take more MC, become more obese. Actually, who take MC? Sick people or healthy people?
Sick people.
Sick people. So who's more sickly? High BMI or normal BMI?
High
BMI.
So what do you want to know between these two?
MC depends on BMI.
Does taking MC depend on BMI? Does taking MC depend on BMI? Why is it important for the employer? Why is this important for the employer?
Because those who fall sick will take more leaves and then.
Right, it is true. We confirm that high BMI more likely to MC than they're recruiting don't take obese people. Right? That's a reason for all this. Okay, let's do this now. Analyze, regression, binary. What's the dependent variable? Let's reset, reset. What's the dependent variable?
MC.
MC, medical leave. Does it depend on
BMI.
BMI? Anyone can't follow? Right. Code option. Forget everything else, just ask for CI, confidence interval. That's all not necessary, just confidence interval. Continue. And click OK. So just two tables. Look at table encoding, dependent variable encoding. Which is the reference group? Here, which is the reference group?
No.
No,
No.
is
Yeah.
right? We're comparing MC versus no MC. And look at the last table. The last table. Is this positive or negative?
Positive.
Positive or negative? This coefficient is positive or negative?
Positive.
Positive. That means higher the BMI, more likely you take MC. Write the equation. Write the equation. What's the equation? Z equals to negative
6.917
0.917
plus 0.238 BMI.
0.238. 238 times BMI. All right. Akita, how many MC have you taken? Are you take MC? Do you take MC regularly?
No, not yet.
Not yet. Okay. Supposing the BMI of a person, let's say put 30 first. What are chances of the person taking MC? First must calculate Z, isn't it?
Yes.
What is that? 30 times 0.238 minus 6.917. Okay, that is Z. Check. This Z, positive or negative?
Positive.
Z is positive or negative?
Positive.
Positive.
Positive means higher the chances of taking MC. If this 0 means 50-50. More than 0 means higher than 50%, more likely. Let's work it out. What's EXP of this value? EXP of Z equals to, by using Excel, I use this. Then 1 plus EXP, right? Equals to 1 plus this value. So what is my chances of taking MC? So probability of taking MC. Right. So it's going to be
55.5%.
right, this over this, which is more than 50%. Okay, more than 50%. Okay, equals to this over this. Right. Let's say a person even more obese, Let's try 35. Try 35. So now for 30 is 55.6%. Let's say obese 35. So change the value to 35. Yeah. Hmm. Mm-hmm. Okay. All right. Okay. Bye. Bye. Okay. Now, what do you see from here? BMI 30, almost 50% chance, slightly more than that, you're going to take MC. Higher the BMI, more likely to take MC. Right? So now I can say obese people 10 are more likely to take MC. We didn't see how many MCs are more likely to take MCs. So the employer, the obese people don't employ them. Questions? Was the class quiet?
No, Prof.
No? Okay. Do you want a break or shall I continue? I'm going to show you how to do the analysis and show in a table. I'm going to take the example obese. Okay, this variable obese. My objective is factors associated with obesity. Right? Factors associated with obesity. All right. Okay, the factors I'm going to consider here from my data. The factors I'm going to consider gender, job, marital, consider these variables. Physical activity, PA, okay. How many levels? Gender, how many levels?
2 level,
Female. Job category,
3
3 levels, doctor, nurse, and attendant.
attendant,
Marital,
3
3, single, married,
married and once married.
okay. Right. Single, married, and once married. Right. PA,
3 rarely, sometimes, and
regularly,
regularly.
sometimes, and rarely. Okay, these 3 levels. All right. Prepare a table. First one, variable. First one is gender. Female versus male. Next variable. Job category. Doctor, nurse, attendant. Next one, marital status, single, married, and once married. Next one, physical activity, regularly, sometimes, and rarely. So we go to the analysis and complete the table based on whatever variables, whatever values are important, and then complete it. All right. Okay, ready? Are you ready?
Yes, sir.
So go to transform, go to regression, binary logistic, variable, obesity, BMI, go out, gender, come in. Gender, is it quantitative or qualitative?
Qualitative.
Qualitative. Therefore, go to categorical and change gender into this box. These were categorical variables. Continue. And click OK. Hold on, hold on. We like to change this one. Hold on. BP category. Okay. Right. Look at this table. Dependent variable coding. Dependent variable. Which is the reference group? Which is the reference group?
No
You're comparing yes to no.
and no.
Next. What's the next? Hold on. Right. Okay. Next table. Categorical variable coding. This is your independent variable, gender, male, female. This dependent variable, normal, obese. These independent variables. Now, which is 1, which is 0? Here, which is 1, which is 0?
Female is 1.
It means female compared to male. This is
Obese
have to
is
change.
0.
Hold on. Look at the codings again. How is obese coded?
2个，
Oh,
One is obese. Yeah. 1, 2.
change the 2 to 0.
2, 0.
我先不走，我先不走，有车，没事。
Transform, recode into same variable, recode into same variable. Now bring obese into the box, obese into the box, old and new, all value 2, make it 0. 2 become 0. Continue. Click OK.
Prof, can't we just change the label there?
Can. Straight away we can change. Now must change the number. Instead of 1, 2, must change to 1, 0. It's not label, okay? Instead of 1, 2, must change to 1, 0. Right.
We can manually change it on the in the values, right, Prof?
You can go here and change this again. Correct?
Yes. Yeah.
So now these zeros are the normal cases. So I'm going to relabel this 0 is normal. So instead of 1, 2, I'm using 1, 0. All right. Let me do the analysis again, logistic. Okay, look at the tables. Dependent variable, this independent variable. Dependent variable, obese compared to normal. Categorical variable, female compared to male. The 0 is a reference group. So in completing this table, to complete this table, right? Who is a who is a reference category here? Who is a reference category?
Male.
Male, right? So male. So take this, go to the last equation. This last equation. The EXP is called the odds ratio. The EXP is called the odds ratio. We just call it OR. Take the B, EXP exponential of B become of this. Can you try this? The calculator or your endpoint. EXP of 3.214. Does it become this? Can anyone verify that? Equals to EXP of this value 3.214. That's a value 24 point something. Right? Right here?
23.10. Like, I think approximately. Yeah.
Again?
It's nearly 23.10 something.
Yeah, this automatically calculates for you from here to here.
I took 3.14, so it is 3.21, right?
All right, let's see. So now we want to put the values. This is called OR bracket 95% confidence interval. That's what I'm going to report. Look at the OR value. Female 24.889 bracket. This is a lower limit. That's upper limit. 9.042, 69.68, 68.506. Okay. This is for male or female. Look at gender 1. Gender 1 refers to, look at this table. Gender 1 refers to which variable? Gender 1 refers to female.
Female.
Gender 1 refers to female. So here this table, gender 1 refers to female. And where's male? Where is male? Male is a reference group. Here I put 1. Male is a reference group. How to interpret this now? And okay, put a p-value. So what's the p-value? In this table, gender. So take this p-value. So what's the p-value?
Less than 0.001.
Right, less than 0.001. Then we don't need this table. Column. Okay, now, what's my objective here? What do I want to know? What's my objective?
Whether there is an association between gender and obesity.
Right, so this measures gender and obesity. Obesity may be yes or no, right?
Yes.
Gender, female over male, isn't it?
Yes.
Male is a reference group. How to interpret this? Is there an association? Is there an association?
Yes.
At p-value less than 0.05, there is an association. Next question, how? Now it's saying the odds of a female being obese is 24 point, maybe 2 decimal place, 95% CI. Times more compared to the males. Right? Gender and obesity. Now just watch this. What I done earlier, gender and BMI. We compare gender and BMI. So here we say female. Now what's the objective? You want to know whether
Association,
between gender
gender and obesity.
What's the answer? Is there an association?
Yes.
Yes. What's the next question? Is there an association?
Yes. How?
How? Now, that's how you interpret this way. The odds of a female being obese is 24.8 times more compared to a male. The odds of a female being obese. So who is a higher risk, male or female? Who is higher risk?
Female.
Female is higher risk. Factors associated with obesity. So we say females are at higher risk. Right? Questions? Always there must be one reference group. Let's go to the next one. What's next variable?
Job category.
Job category. Right? Job category. Is it qualitative or quantitative?
Qualitative.
Right, good option. A categorical. Categorical. Bring this into this. Okay. Now, before we continue, I'm talking about odds, isn't it? Do you understand what's odds?
Chances.
Chances. Is odds the chances? Okay, we diverge a bit. You want to go and talk about what's odds. Let me demonstrate. Any football fans here? Any football fans? Did anybody watch football? No.
Yes, we watch. Yeah.
Okay, which is your favorite team? Which is your favorite team? If somebody say something, which is your favorite?
Paris Saint-Germain.
Huh?
Paris Saint-Germain. Paris Saint-Germain.
Are they going to win the championship? You think they win the championship?
In this.
Huh?
Yeah, the last time, yeah, they win. Yeah.
Okay, this time? This time?
They are on the way. Not sure yet.
Okay. So either they win or they don't win, right?
Yes, sir.
The odds is winning over not winning, right? So let's talk about this. We talk about exposure and unexposed. I give some example of it. And here, let's say event. Here, no event. You can quote many examples. We're going to talk about what is odds and odds ratios. Let's say I put A here, this B, this C, and this D. What is this A denote? What is A denote? Analogy, smoke, no smoke, cancer, no cancer. All right. What is A? A is a count. Count of what? What is this cell? What is this cell denoting? From here, what is this cell denoting?
Those who smoke and have cancer.
Cancer, right? So A equals to cancer, smoke, and cancer. What is B? What is B?
Smoke, but no cancer.
Smoke, no cancer. What is C? What is C?
No
Don't
smoke.
smoke but get cancer.
No smoke, but cancer. Okay, no smoke, but cancer. What is D?
No smoke, no cancer.
This is no smoke, but cancer. This, no smoke, and no cancer. So in this here, 4 cells now, the A, B, C, D, smoke and cancer. Now, given this, how many variables are there? How many variables are there?
2.
2 variables. What are they? What are the variables?
Smoke and cancer.
Smoke, yes, no, that's one variable. Cancer, yes, no, that's another variable. A is number of smoke and cancer. What's the odds now? How is odds defined? Odds defined as event over non-event. In this case, cancer or no cancer. The odds is A over B. The odds here is C over D.
So it's a probability, right?
It is not probability.
No.
I show you why it's not probability. Okay. Example. Let's give some quantitative numbers to show why it's not. Okay. Let's say this value is 100. I'll make it smaller. 20. This is 30. This is answer 10. This is 50. So what is the odds value here? What's this value? How much is this? 20 over 30.
0.66.
This over this. Not this over the total. 20 over 30. So that's the odds for the two groups. Now, why this cannot be probability? Supposing this value is 40, is this value more than 1?
Yes.
Probability can it be more than 1?
No.
No. So this is not probability. So what's the definition of odds? Definition of odds is event over non-event. Odds equals to number of event over non-event. That's the definition of odds. So this class, I just introduced what's the odds. So in our case just now, male, female, this was female, right? That was female. This was male. Here we had obese and normal in the example. Did I?
Yes. Yes.
Okay, this is the odds. Then what's the odds ratio? Just OR. What's the odds ratio? Odds is simply the ratio between the two odds. The ratio between the two odds is called odds ratio. Right? So that's the odds ratio. Is it possible odds ratio equals 0? Or is it possible odds ratio equals to 1?
Yes.
Yes. Odds ratio equals to 1 means what? OR equals to 1 means what?
A is equal to B.
Say again. When is OR equals 0? Equals to 1.
When A and B will be equal.
When there's numerator same as the denominator, right?
Yes.
My objective is whether the exposure is the risk factor for the event. OR equals to 1, that means no. Is it possible OR more than 1?
Yes.
More than 1 means higher here compared to here, right? When this value is more than 1, means this is higher compared to here, right?
Yes.
Off here higher compared to here. Is it possible less than 1?
Yes.
Or less than means what?
Chances of
A
event.
less than B.
This is lower compared to here. So asking whether an exposure is a risk factor for an event. Ultimately, the OR maybe is 1, maybe more than 1, or can be less than 1. So OR is the ratio between the two odds. In our example just now, the odds ratio for female being obese is almost 25 times. That means the odds of a female being obese is 25 times more compared to the males. So in this particular study, the females are higher risk of being obese compared to the males.
Yes, Prof.
That's all you want to know. I don't want to go in detail. That's all you want to know. Right? Let's try another variable. Logistic. We have job category now. Categorical, job category. Continue and click OK. Does job category make a difference? Look at the p-value. Job category, does it make a difference?
Yes.
Yes.
Next question is how? So job category 1, 2 here. The 1 refers to whom?
Doctor.
Right.
Oh, sorry, attendant.
The 1 refers to attendant. 2 refers to?
Nurse.
Nurse.
And doctors are reference.
There's a reference. So how to interpret? How do you interpret? The 1 refers to whom? The 1 refers to attendant compared to doctor. I put A over D. Attendant compared to doctor. Okay, the job category 2 refers to? The 2 refers to? Nurse compared to doctor. Right. So forget all the other values. Just refer to.
Prof, in Like since we are treating doctor as a reference, so attendant and nurse will never be compared, is it?
Say again?
Since doctor is treated as reference,
Ah,
so attendant and nurse will never be compared, right?
now let's see how you interpret this. So this is the p-value. What is it comparing? Attendant and doctors. The p-value, is it more than or less than 0.05?
More than 0.5, 0.
There's no difference between attendants and doctors. Let's see next one. What are you comparing here?
Nurse and doctor.
This is nurses and doctors. Is there a difference?
Yes.
Yes. This value, is it more than 1? This is odds ratio. Is it more than 1 or less than 1?
More than.
More than 1.
More than 1 means what? The nurses higher odds of being obese compared to doctors.
Doctors.
Because odds ratio more than 1 means at higher risk, right?
Yes.
And I'm not using the word chances, the odds are higher for the nurses to be obese compared to doctors.
Yes.
So as you go on higher and higher levels, so whatever I studied so far may not apply in your PhD because they're all just basic understanding of statistics. As what you're going to do after this should be more relevant to your research, right?
Yes.
So next week, you're going to move into details of multivariate. That's why I'm going to apply. But the basic, whatever learned until today, that's why I'm going to apply in your future research. Okay. Have you all decided already what exactly your research is going to be all about? Have you all decided what the research is going to go about? What about your research?
Not yet, Prof, for me.
Not yet. But your resilience, right?
Yes.
Resilience among hotel workers, right?
Yes.
Right. How long already into the program? Your PhD or master's?
I'm PhD. My intake is last year, October.
Last year, October. Okay, still early. Right. As you go, think whether whatever you're learning in this statistics course be applied in your research or not. Ankita, what are you doing? Ankita,
Yes, Prof.
what's your research about?
Detecting spoofed speech, whether it's spoofed or normal.
Say again?
Detecting spoofed speech, whether the input speech is normal or natural speech or the spoofed one.
Okay, that means the outcome is speech, isn't it? Whether it's normal or
Output is in the form of binary 1, 0.
binary.
Yeah.
So ultimately, you want to see what are the factors associated with it, right?
Yes.
So what's your target population? Where the study be conducted?
Professor, actually, target population doesn't matter at this stage. I think we work on databases which are already available rather than creating ones because this kind of approach is based on already conducted or attacked systems. So
Okay, that means you want to look at the patterns, right?
yes.
All right, but the outcome is yes, no, isn't it?
Yes.
So yours will be towards binary, isn't it?
Yes.
We'll be talking more about odds ratios, these kind of things.
So it's a classification task.
Okay. Arafat, what's the research about?
Hi. I'm running like investigation on morphing wing for airfoils.
For what?
For airfoils. It's based on morphing wings.
Okay.
So I will be my research will be collecting, if you're asking for like data that I will need to collect, right? Is that what you're asking?
So is that an outcome variable?
Yes, there is. It's a coefficient of like lift and drag. So it's based on that, and then try to see the difference between the reference data, like the reference airfoil that exists, and then I'm designing a new one that is the optimum one.
All right.
But yeah.
Biju Matthew.
I'm on teaching practice.
Okay.
It's a quality teaching practice to come up with a framework for quality teaching practice.
For what?
Quality teaching practice.
Okay, quality teaching practice. How do you know it's of quality?
Yeah, it's
there must be a measure, right?
Yeah, to measure the current practices and the problems faced by it.
The problems faced by it.
Yeah.
So how do you identify the problem? Is it yes, no?
It's through the survey.
Or survey.
The what is called the sample or the targeted population.
All right.
I'm focusing on somewhere around 600 the population.
All right. Okay.
Prof.
Yeah.
Deva. Yeah. Perhaps Prof, I need maybe you can give me some ideas as regarding my research. Actually, it's about a teaching strategy. So there will be like a control group and experimental group. So any ideas I can do about my research?
Okay, teaching what subject?
Education.
Education, is that?
Yeah, English, yes.
Teaching.
Basically writing.
English writing, is that?
Yeah, yeah.
Okay. You're going to break into 2 groups?
Yes.
You're going to test a new method of teaching?
Sorry, come again?
Method of teaching?
Method of teaching.
Are you going to compare 2 methods of teaching?
No, basically one method. I'm going to use one method, one teaching strategy, yes. So to see like the outcome, whether they have improved or not before and after.
Okay, before and after, right?
Yes.
So you're going to baseline measurement and then introduce the teaching and then post-analysis, you're going to measure again, right?
Yes, yes, exactly.
Same students measure before and after, isn't it?
Yes, yes.
Right. But is it better to have control group as well?
Yeah.
Control group.
Control group, yeah.
Baseline, let's say I take 2 classes. Both classes give baseline test.
Okay.
And then one class will go into treatment, the new method of teaching.
Yes, treatment, yes.
Other class, traditional method. Post, give a test again and see whether the new method of teaching students improve more compared to the control.
Okay.
And naturally, both the group will improve over the time, right?
Yes.
But you want to know whether the new method of teaching
significant, yeah,
is significantly higher.
Yes.
Right. So the demographics of the students, does it matter?
Yeah.
Right? Demographics.
Yes.
So it won't be simple t-test.
Sorry?
It won't be simple paired sample t-test, okay? You got 2 groups, right?
Yes.
The example we did for paired sample t-test, only 1 group, isn't it?
Yeah.
And no demographics.
Oh, okay.
The girls may fare better than the females.
Yeah, yes.
Possible?
Yeah, yeah, yeah.
Right. So
possible,
most likely, you'll be using generalized estimating equations procedure. Generalized
estimating
equations.
Equations, okay.
So in your, look at the screen.
Okay.
Using this procedure.
All right.
So go and read up. It's asking what procedure you're going to use later.
All right.
Well, none of those we learned until today are going to use it. Usually on a higher advanced levels. Yours most likely will fall into this group.
Okay.
All right?
All right.
As you go and see whether what is studying is sufficient for your PhD or master's thesis. What else do you require? That's why literature is very, very important. Read up.
Okay, sure.
Let's see that. Just follow. Right?
All right.
And
yes, Prof.
Let's talk about your research.
Okay, mine is how personality traits may be correlated to how teacher-student relationship and teacher well-being.
Okay, teacher well-being. How do you measure teacher well-being?
There is a scale.
There's a questionnaire.
Yes, there's a questionnaire with a scale.
So it's a continuous measure or categorical in the end?
It'll be a categorical one.
Categorical. How many levels?
It will be 5.
5 levels. Huh?
I'm not really sure about it. I think it's about 5.
Okay.
I haven't looked at it.
In my example just now, I took BP as a continuous.
Yes.
It's in 2 levels, high and normal, isn't it?
Yes.
So that will be logistic. I want to know whether categorized in 2 levels or more than 2 levels. Example, stress. Stress among
yes. Well, it is looking more at stress than it is looking at well-being at the moment. Right. So the levels are different. It's not just yes or no.
Right. We use the DAS 21 instrument, DAS 21, yes. Depression, anxiety, and stress. There are 5 levels in each. Right?
Yes.
So the outcome is going to be 5 levels. And talking about factors associated with the outcome, isn't it?
Yes.
So what analysis are we doing? So you have to think in more detail now itself, what people have used in a similar studies. Right?
Yes.
Yours could be something like ordinal regression.
Ordinal regression.
Ordinal regression. I mean, as you go, you build up, okay?
Yes.
It can be ordinal because the stress level is ordered, isn't it?
Yes.
Mild, moderate, severe, these kind of things, right?
Mm-hmm.
So all of you concentrate on what is the outcome and how it will be measured. Is it quantitative? Is it qualitative? Is qualitative? How many levels? All right?
Yes. Prof, can I just ask, the definition for teacher well-being, they say that it changes along with many factors that might affect it. So if there was a longitudinal study to be done, do we actually have to do some sort of an intervention